Hey guys, it's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to write and explain a recursive formula for an arithmetic sequence. You should also be able to distinguish between an explicit and recursive formula for sequences. And finally, you should be able to translate between recursive and explicit forms for sequences. Now, another way of finding a term of an arithmetic sequence using the previous term is called the recursive formula. If you recall from yesterday, we had a sequence which read 5, 7, 9, 11, 13, 15, 17, 19, and so on. How can we calculate the sixth term based on the fifth term? Now the sixth term is 15, the fifth term is 13. So from 13, how do we get 15? Well, we would just add 2. Now, how about the eighth term from the seventh term? So from 17 to 19, we would also just add 2. So in general, how can you calculate the nth term? So any term. So in general, how could we calculate the nth term based on its previous term? Well, we just add 2. So then the recursive formula for the sequence is going to be written as a sub n, which would be any term, is equal to a sub n minus 1, so its previous term, plus 2. And it kind of makes sense with this sequence that we have for this example. We have some term, and in order to get the next term, we just add 2. Now there's a little bit of notation that we should go through. We've got a sub n, which is just the nth term. There's a sub n minus 1, which is the term before the nth term. And we might also see a sub n plus 1, which is the term after the nth term. Now let's take a look at a couple examples. So we have a sequence, an arithmetic sequence that reads 4, 6, 8, 10, and so on. Now let's find the common difference. Now common difference again is how much each term goes up by or down by from one term to the next. So from 4 to 6, we see that we're increasing by 2. From 6 to 8, we're also increasing by 2. From 8 to 10, we're increasing by 2. We'll note that since we're increasing by the same number for each consecutive term, this is an arithmetic sequence. And then the common difference is going to be positive 2. Part B, find the first term, a sub 1. Well, that's pretty straightforward. What's the first term in this sequence? Well, a sub 1 is going to be equal to 4. Now this is now going back to what we started with. How could we find the next term based on the previous term? Well, we must add 2. Here's the new part. We're going to write the recursive formula for the sequence. Now it's going to maintain the same structure, so we should start with a sub n. That's going to be equal to the previous term, a sub n minus 1, plus the common difference. And that's it. Using this idea, let's now calculate a sub 5, 6, and 7. So the 5th, 6th, and 7th terms of this arithmetic sequence. So the 5th term is going to be equal to, and we're going to use our recursive formula, the previous term, which is a sub 4, plus the common difference. Now we know that a sub 4 is equal to 10, so it's now going to be 10 plus the common difference, which gives us 12. We can do the same for the next term. So the 6th term is going to be a sub 5 plus our common difference. And we just figured out that our a sub 5 is equal to 12, so this is going to be 12. Oh, bugger. And our common difference again is 2, so that means our answer is going to be 14. Now our 7th term has to do with the 6th term, so a sub 6 plus our common difference. Our 6th term was 14 plus our common difference is going to give us 16. So a sub 5 is 12, a sub 6 is 14, and a sub 7 is 16. Now, let's recall how to write an explicit formula. So, the structure for an explicit formula, if you recall, is a sub n is equal to first term of the sequence plus n minus 1 times the common difference. Let's start plugging in some values that we know. We don't know a sub n, so we have to keep that. The first term in our sequence, if you recall, was 4, so we're going to go ahead and write 4 for a sub 1 plus n minus 1, n being any term that we choose, times the common difference, and let's go ahead and take a look again. Common difference for part A was 2, so that means that we're going to multiply this quantity by 2. Let's distribute and simplify as much as possible. So what I'm going to do is I'm going to distribute this 2 to each of the terms on the inside of this parentheses. So we've got a sub n is equal to 4 plus 2n minus 2. We've got like terms that we can combine, which gives us 2n plus 2 as our explicit formula. Now using this, let's calculate the 20th term, so a sub 20. So a sub 20 is the same thing as plugging in 20 to our explicit formula. So we get 2 times n, where n is going to be 20, plus 2, our common difference, plus 2. 2 times 20 gives us 40, plus 2. Make sure we're following our order of operations. So multiply first, and then finally we can add to get 42. So a sub 20 is equal to 42. So example 2 reads, using the general explicit formula, generate the 5th term of an arithmetic sequence whose first term is 3 with a common difference of 6. I'm going to go ahead and write the general explicit formula. That was a sub n equals a sub 1 plus n minus 1 times our common difference. let's start plugging in some values that we know. We're looking for the fifth term, so a sub 5. We know that the first term is 3. We're looking for the fifth term, and our common difference is 6. Following our order of operations, we need to work parentheses first, then multiplication, then we can add. So, parentheses, 5 minus 1 gives us 4. Then we can multiply. And finally, we can add. So our final answer is going to be 27. So the fifth term in this sequence is 27. All right, so part B asks, if Jacob said that a sub n is equal to 3n minus 1, then a sub n plus 1 is equal to a sub n plus 3. Do you agree with Jacob? Why or why not? Now, this one's going to take a little bit of work. We're going to start with one formula. We're going to start with one equation, and then we're going to work on the other one. The idea is we want to see if we can get them equal to each other. Now, if you notice, both of these equations have a sub n in common. So, what I want to do to the equation on the right, so the second equation, I'm going to try and manipulate that so a sub n is by itself on one side of the equal sign. In order for us to do that, we must subtract 3 from both sides. So what we wind up getting is a sub n plus 1 minus 3 is equal to a sub n. Now, the first equation said that a sub n was equal to 3n minus 1. Because both of these equal a sub n, they must be equal to each other. Okay, I'll say that one more time. Because both of these are equal to a sub n, that means they must be equal to each other. So 3n minus 1 must be equal to a sub n plus 1 minus 3. Now let's try and manipulate this to get a sub n plus 1 by itself on one side of the equal sign. What I'm going to do now is add 3 to both sides. And what we get is 3n plus 2 is equal to a sub n plus 1. So that is part 1 of this proof. So that is part 1 of this explanation. Part 2 is now manipulating the second equation. A sub n plus 1 is equal to a sub n plus 3. Now the first equation tells us what a sub 1 is, so I'm going to substitute that into the second equation. What I mean is I'm going to take a sub n plus 1 equals, instead of a sub n, I'm going to take this entire expression, this 3n minus 1, and that's going to now be in place of a sub n. Now let's try and simplify this, combine like terms. We wind up getting a sub n plus 1 is equal to 3n plus 2. And if you notice, that's the exact same thing that we got on the other side of the equations. So, I would agree with Jacob, and we've just shown that. Again, part C I'm going to leave for you. Let's see what you can come up with. At this time, I'd like to take a look at a couple more examples. We're going to go ahead and write some recursive formulas for some arithmetic sequences. So we're going to try a couple of examples, and I'm not going to do all of them. I'm going to do a couple of them for you. You guys can finish off the rest after the video. So in example 3, or this set of problems, we're given a sequence, an arithmetic sequence, and we're asked to write the recursive formula for each sequence. Part A is given to us. Its sequence is 6, 10, 14, and 18. The first term is 6, and then the common difference, if you notice, going from one term to the next, you're just adding 4, which is represented in this formula. So there's two things that we're trying to write for. So there's two things that we should write for a recursive formula. Our first term, and then the general formula using the common difference. Now first term in this sequence for part B is 12. Now to finish off the recursive formula, we're going to go ahead and use the structure a sub n is equal to a sub n minus 1 plus the common difference. So going from one term to the next. So from 12 to 24, we added 12. From 24 to 36, we added 12, and so on. Because it's a constant or a common difference, because it's a common difference, so the common difference is 12, which is what we'll write here. So this entire thing is our recursive formula. Let's try one more. I'm going to go ahead and take a look at question E. So question E, the sequence is 8, -3, -14, -25. We know that we need our first term, so a sub 1 is equal to 8. And let's take a look and try and figure out what the common difference between consecutive terms is. So to get from 8 to -3, so that's -3 minus 8. Notice that we're decreasing, so we went from a positive number to a negative number. So that means we have to be subtracting. We're not adding anymore. We're actually subtracting 11 to get the next term. To go from -3 to -14, notice again we're going more negative, so this is going to be a -11. And then we can keep going again from -14 to -25. Our common difference is -11. So then the rest of our recursive formula will look like this. Same structure. We're looking for the nth term. We need to know the n minus 1 term. And then we're going to throw in our common difference. Again, I'm going to leave the other 3 problems for you to try. I'm also going to leave this challenge for you. It's pretty neat. I think you should try it. But at this time, I'm going to go ahead and recap. And then you can use the rest of the time that we have left in the period to try the rest of the examples and catch up on any homework if needed. So recap. How does the recursive rule differ from the explicit rule? Now the explicit formula, if you've forgotten already, which hopefully you haven't, explicit is a sub n is equal to first term plus n minus 1 times the common difference. The recursive formula, which we just went through, we need our first term, whatever it is. I'm just going to put a question mark. And we also have the a sub n, so the nth term. It's going to depend on the term right before it, and we're going to add on our common difference. So what's the difference between these two? What does one formula have that the other doesn't? And that's where I'm going to let you explain in your own words how the recursive and explicit formulas differ from each other. Have a great day.